So the question that we're left with here is, how do oligopolistic firms, how do they determine the prices that they're going to charge? So you'll remember from the discussion of monopolistic competition and perfect competition that firms determine their prices by setting the marginal revenue equal to the marginal cost. And then they either go up to the demand curve, or the marginal revenue curve was the same as the demand curve. Well, in oligopolies, it's a little bit different, because firms that are oligopolies are actually called price searchers. Now, this is a very significant difference, because under perfect competition, firms were price takers. They just took the market price as given. And to a large extent, monopolistically competitive firms also just took the market price. They had some slight differentiations in their good, and they had some pricing power, but not a great deal. What's significant about then the oligopoly is that they do have significant enough of pricing power that they actually need to find the right price. Now, as price searchers, technically speaking, they still do set marginal revenue equal to marginal cost. But that's not how we're going to look at it in this chapter. What we're going to do instead is we're going to look at it excuse me. We're going to look at it with a firm that exists as in a game theoretic standpoint. So under game theory, what we're trying to do is we're trying to plot out how firms strategize with one another, with existence that the other is engaging in the same types of strategies. Okay, so I'm going to draw out a game, I guess, what economists call a game. But what we're going to do is I'm going to plot out a game that shows the payoffs. This is going to be called a payoff matrix. And what we're going to have are two players in this game, two firms that are competing with one another. And they're going to be presented in this game with this payoff matrix. And they're going to have to make decisions based on with knowledge that the other firm is also making decisions. Okay, so I'm going to start to write this out here and then explain the nature of the game. So I'm going to pause the video here for a second. Okay, so we're going to be looking at then the strategic decision-making behavior of individuals. And we're going to be looking at this in terms of a Nash type of game. These are non-cooperative games. Now, Nash, that name may be a little bit familiar if you've seen the movie Beautiful Mind, which profiles actually John Nash as he actually is coming up with game theory. And then he goes crazy, and he's got that wife that he breaks up with and he gets back together with. It's got Russell Crowe in it, who plays John Nash. These are going to be non-cooperative games, so we're going to have two-player games where neither party is trying to help the other. They're just looking out for themselves. And what we're going to be looking for in these games as we set them up is we're going to be looking for the dominant strategy. This is defined as what a player would choose to do regardless of what the other player chooses to do. So a dominant strategy would mean they don't even necessarily care what the other firm or what the other individual is doing. They'll always do the same thing. So what we're going to set up here is a very simple kind of non-cooperative game, just to introduce this topic, known as the prisoner's dilemma game. So just to set it up, a crime has been committed, and two individuals were captured by the police. In capturing these two individuals, they know that someone committed the crime, and neither of the two that were caught can talk to each other. So in the way that this is, they basically are going to face a choice of whether to confess or not confess. Now, the cop who caught them, he likes an honest person, and plus, if a confession is made, it actually makes his job really easy, because it makes conviction really easy. Things are really not going to be that costly. So we can set up the game where player 1 can choose to not confess or confess to the crime. Player 2 can choose to not confess or confess to the crime. And what would be on the top then is going to be player 1. And on the bottom is going to be the payoff for player 2. So, bear with me here for 1 second here while I quickly write this out here. Okay, so if player 1 chooses to not confess and player 2 also does not confess, they would each have to pay a fine of $2,000. If they both choose to confess, well, then what happens is that they, in this case, at least there's a chance that, neither of the two that were caught were actually guilty of the crime. Here, it's going to be really, difficult to convict two people of having committed one crime simultaneously. And in this case here, you've got the one individual who's confessing, right? And that makes it cheaper for the sheriff to convict the person. And you got one person who said they didn't do it, but they look pretty suspect. So you're going to give them a really big fine, because they must have done something wrong if they were in the area where the crime was committed. So the first task is finding the dominant strategy. The way that we do this is we set this up as an if-then statement. If player 1 chooses to not confess, what does player 2 do? Now, right, the goal here is to pay the lowest amount of a fine. So, if player 1 does not confess, what does player 2 do? Well, player 2 would face then either a fine of $2,000 or a fine of $500. Obviously, they would want to confess in that kind of situation if player 1 did not confess. Now, what if player 1 confesses? Then they would face either a $5,000 fine or a $3,000 fine. Again, they would choose to confess. This is a dominant strategy. Regardless of what player 1 chooses to do, player 2 always confesses. Now, what about player 1? What is their dominant strategy? Okay, so if player 2 chooses to not confess, then player 1 either is going to have a $500 fine or a $2,000 fine. Obviously, they would want the lower of the fines, the $500. What if player 2 confesses? Then they would face either a $5,000 fine or a $3,000 fine. Again, player 1 would choose to confess. This is, as well, player 1's dominant strategy. That's what I'm circling here, is confession. Where the two dominant strategies intersect, that's actually going to be useful for us. It's actually called the Nash Equilibrium. In the Nash Equilibrium, what we're basically saying here is what is the best option for each player with full knowledge that the other player is doing the best that they can do. In this case, player 2 will have a dominant strategy of always confessing, player 1 always confessing. This is an equilibrium. This is a stable point. Each player doing the best that they can with full knowledge that the other player is doing the best that they can. Now, what I want you to look at just very briefly, though, is look at what this situation would have produced. So here they're going to each pay a fine of $3,000. They're both going to confess to the crime. Had they both been able to agree on something, or could we have found a cooperative equilibrium, they actually could have both gotten away with paying a lower fine. If they both had gotten a chance to talk to each other and said, okay, let's just both not confess to the crime. We're going to get that. We only have to pay $2,000 rather than $3,000 each. Now, that cooperative equilibrium, unfortunately, is not stable. And the reason why it's not stable is because each player faces a strong incentive to defect or to go against their word. Right? Player 1 and player 2 get together and they say, we're both going to not confess to the crime. Well, then player 1 can say, you know what? I don't know this other player. I'm going to confess to the crime when the other one's not confessing and pay a fine of only 500. Right? So if the game is played by individuals who are looking out for their own self-interest, any agreement is probably going to be unstable unless you have a way to enforce it. This is important for oligopolies because what we then find is that they all, in some sense, acting in their own self-interest, they actually result in a situation that's not 100% optimal for them. This situation right here. This cooperative equilibrium is unstable. This uncooperative equilibrium, however, is stable. Okay, I'm going to pause the video here and then actually look at this same kind of game, the Prisoner's Dilemma game, and actually apply it to two oligopolistic firms. We're going to look at the retail store industry, and we're going to look at a Target and Walmart example. So I'm going to stop the video here just in terms of time, and we'll do the third and final part.